Yo, 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 yo! This is Mr. G, and this is the video for ordering real numbers. So 1.3, the last one of Module 1. So if you haven't watched all the other ones before this, make sure you do that first because you do need to know all that information because now we're going to combine it all into nice one big summary here. So let's get after it. So first, let's talk about what we're doing. We are going to compare and order real numbers from least to greatest, or compare them to see which one's larger or smaller. So, and we're going to place them on a number line. Now, the way we do that is we need to know approximately what the value is of each number in order to order them from least to greatest, or to compare them. So what we can do is if we have square roots or if we have imperfect squares, we can approximate them, estimate them to the best decimal that we can. If we have fractions, we can convert them to decimals, but we want everything to be either a whole number or a decimal of some kind because then it's really easy to compare numbers. So, like this one right here. This one I have the square root of 3 plus 5. I also have 3 plus the square root of 5. And I'm just determining which one's larger. So, what I need to do is I need to figure out, well, exactly what is this equal to? We can't just say, well, 5 is larger than 3 because maybe 3 plus the square root of 5 is actually going to give me something larger than this. I don't know. So what I need to do is I need to figure out, well, what is the square root of 3? What is the square root of 5? And then I'm going to add that to 3, add that to 5, and then I can actually compare them. So I'm going to actually evaluate this little expression right here. So for the square root of 3, I need to do my approximation. And the square root of 3 is going to be somewhat close to 2. Okay, because if I go off to the side here, square root of 3, it's in between 1 and 4. It's a little bit closer to 4, which means it's pretty close to 2, so it's got to be 1 point something. Okay, well, it's 1 point, it's a lot closer to 4, so I'm going to go 1.8 is my estimation. So 1.8 plus 5, or maybe even 1.7 would even be a better one. 1.8, 1.7. But when I get my estimation, now I'm actually going to add that with 5. So I'm going to line up my decimals. 5 plus 1.8 is 6.8. So I have a nice approximation of what this is equal to. Now I'm going to do the same thing over here. So I have 3 plus the square root of 5. Well, I know the square root of 5 is in between square root of 4, square root of 9. So that means it's in between 2 and 3. And it's pretty close to 4. So let's just go with 2.2. So if I have 3 plus 2.2, that's 5.2. This side is larger. Now I know that this whole side is equivalent to around 5.2. It's not exact because I did an estimation. This side is equal to around 6.8, so this side has to be larger. So I'm able to compare them by actually evaluating and making it a decimal. Another type of problem that you're going to do is you're going to have to order them from least to greatest on a number line. So what I would have to do here is I would, again, it's nice to either have the fraction, it's nice to have the decimal equivalent if I don't know exactly what it is. And then that's that. So if I have the decimals, it's really easy to place on a number line. So first, pi plus 1, I know pi is 3.14. 3.14 plus 1 is 4.14. 4.5, well, that's 4.5. And then now I got to figure out what the square root of 22 is. Well, square root of 22, I'll go off to the side again, is in between square root of 4, square root of 16 and square root of 25, which means it's in between 4 and 5. So it's got to be 4 point something. So obviously that decimal does matter because looking here, I have 4 point something, 4 point something, and I want to order these from least to greatest. So this is where we have to use those tools that we learned and realize, well, it's 6 away from 4 and it's only 3 away from 25. It is closer to it's closer to 5 than it is to 4, which means it has to be past 4.5. So I'm going to go with 4.7. But I know that it has to be greater than 4.5 because this value is closer to the square root of 25 than it is to the square root of 16. And that allows me to order them from least to greatest. So I have to then put these on a number line. So a couple things. Whenever we order from least to greatest, we use our original values, not our decimal equivalents. We actually use the original values. And we make our number line. Sometimes we get to choose how we want to make it. So let's see, I got 1, 2, 3, 4, 5, 6, 7, 8, 9. So I know, I'm just going to count by my tenths here. This is 4.1, 4.2, 4.3. Now I'm going to skip because I've showed that these are all tenths, 4.5, 4.7, 4.9. So I made my number line. It's going from 4 to 5. And then now I can place these values on the number line. Pi plus 1, we know it's 4.14, so that's going to be right here. Here's pi plus 1. And notice how I'm using pi plus 1 and not 4.14. 4.5, that's right here. Square root of 22 is 4.7 was my estimation. So I put them on a number line. I order them from least to greatest. Okay. So if I'm ordering them from least to greatest and I'm putting them on a number line, like again, a reminder, it's really a lot easier to then change them into decimals. Okay, it's a lot easier. So what I want you guys to do is try 5 and 6. So we're using all the skills we've learned from all the other videos so far, and then we're going to place these on the number line. The number line's already been made for us, so let's order them from least to greatest with the original given values, not the decimal values. We just use the decimals to tell us what order they go in, but use the original values when ordering them, and then try it out, and then place them on the number line. So try this out, pause it, see how you do. Okay, so for the square root of 5, my estimation is 2.1 because it's just right after 2, in between 4 and 9. So I got 2.1 for that. For square root of 3, I got 1.7. So now I can order these from least to greatest. The smallest number is the square root of 3. The second largest would then be square root of 5. And then my third largest would be 2.5. I know that square root of 5 has to be less than 2.5 because 5 is less than halfway between 4 and 9. So I know it has to be smaller with my estimation. Now I can place these on a number line. Square root of 3, 1.7, we'll go right here. That's the square root of 3. Square root of 5, 2.1 is right here. And I know 2.5 is right there. So that's how your first one should have looked. Now, if you haven't tried the second one already, pause it now and try it. But if you did try the second one, then go ahead and just keep going, and you can check your answers right now. Okay, and here is your order from least to greatest on this one right here. So I showed a little bit of work down here. So pi squared is just pi times itself. Well, that's 3.14 times 3.14. So you actually have to work out that multiplication. And you get 9.8596. And then for square root of 75, I know it's between 8 and 9. And I also know it's closer to 9. So I got 8.7 for my estimation. Well, now I can order 8.7 is the smallest, 9.8 is the second, and then 10 is the largest. So therefore, square root of 75, pi squared, and then 10 on my number line. So change them to decimals, and then it's really easy to order them from least to greatest. So things to remember: approximate square roots before comparing values. So we need to actually evaluate those and figure out what they mean, and then we can approximate, and then we can actually compare to see which one's larger, smaller, which one's greatest, which one's not. Okay, so let's change everything to decimals. Sometimes it's easier to change your fractions to decimals, especially if we don't know exactly what that fraction is as a decimal. And it's really easy to compare once we have everything as decimals. So that's it. Here's your independent practice. Make sure you get that done. And thank you for watching. Gradius out.
Yo, it's Abby, do your math.